Okay. A is activation energy. So the formula for calculate what is activation energy again by definition? Definition of activation energy. It is simply the minimum amount of energy needed for a chemical reaction to occur. That is activation energy. And the formula for calculating activation energy is activated complex. Activated complex minus heat of reactant. This H means heat of reactant or in full. Is that taken? Hello?
Yes.
Okay. So I want to look, let us calculate together the activation energy of this diagram. Let your students know it's very easy. When calculating activation energy, just draw an imaginary line from here. That's how I do this. Then also draw an imaginary line to this activated complex. Maybe it gives me 50, right? Is it not? So EA now is 50, which is my activated complex, minus my reactant is on 30 minus 30. 50 minus 30 should give me 20 kilojoules. That's always the unit, only the kilojoules per mole. That is the activation energy for this reaction. Hello?
Yeah.
Any question? Any question? Please, I would love if you can unmute your mic so that I will get a response or feedback from your end. Is there any question before I continue?
No question.
Okay.
No question.
Okay. Now, for a chemical reaction to undergo or complete process, that means forming a product, the colliding particle now, which are the reactant, remember we said collision theory states that for every chemical reaction to occur, there must be effective collision between the reacting particles. That means these particles that are inside this reactant, their energy must be greater than 20 so that they can climb this place and get a product. That is when you cannot say that the reaction is effective. If the colliding particles has energy less than the activation energy, that means, for example, the colliding particles, some of them are having like 10, 15, while some are having 30. Those particles with 30 or greater than 20 will collide and form a product, while those with less than 20 will still remain as reactants. They will not form the product because the particles don't have energy enough to break this barrier. So that is what we mean by activation energy collision theory. Any issue?
No.
Okay, so let's move on now to next thing. Factors affecting the rate of a chemical reaction. Factors affecting the rate of a chemical reaction. Factors affecting the rate of a chemical reaction. Can anybody help me with one of those factors?
Temperature.
Okay, thank you. Temperature.
Pressure.
Pressure, thank you.
Concentration.
Thank you. As you are listening them, you're writing them, but that's just there. Temperature, pressure, concentration. What else? Catalyst. Sunlight. Concentration. Nature of reactant. Or you can call that one surface area. That is in terms of nature of reactant. So these are the factors that affect the rate of the chemical reaction. Temperature, pressure, concentration, nature of reactant or surface area, catalyst, sunlight. Are we ready?
Yes.
Okay. Now the next thing is let us explain each of them and how it affects the rate of the chemical reaction, and we'll move on. So, do you have any issue with this? Or should we leave it? Since there's no issue.
Oh, I have issue with it, oh, please.
Okay.
Most especially the question like how does the
Temperature.
rate of reaction affect the temperature, affect the pressure? Will it increase or decrease?
Okay.
Something like that.
Okay, I know what you're talking about when we get to that one. But all the same, let's just do something now. Okay, so let's start with the first one. Surface area. Surface area. Now, in this, before I move on, what they will ask students is this. Maybe, for example, define pollution theory. List maybe 4 factors that affect the rate of a chemical reaction. Another is again is how does temperature affect the rate of a chemical reaction? Just like that. So first of all, let's start with surface area. Remember I said surface area could also be called nature of reactant. Are we ready?
Yes.
Okay, so you can write the more surface area between reactants, the more surface area between reactants. Sorry. The more surface area between reactants, the higher the rate of reaction, and vice versa. The more surface area between reactants. Are you ready? The higher the rate of reaction, and vice versa. Vice versa means the other way around. Can we move on?
Yes.
Okay. Let me do a very simple. So when teaching your students again, instructional material that you can use for this area: water, beaker. Maybe you can use your reactant such as sodium chloride, like your normal table salt. Not so big, just small quantity. And also you can use another is calcium oxide. Those ones, you can use those ones as instructional material. Now, how does this play? Can write note. Note, let's write this first. Note. The smaller the size, the faster the rate of the reaction. The smaller the size, the faster the rate of reaction. Because of a greater surface area. Because of a greater surface area. That's okay.
Yes.
Okay. Now, how do we explain this? If I have this, 3 different beakers, both or 3 of them all contain dilute HCl, that is dilute acid. One of them inside I have powdered CaCO3 with dilute HCl, that is dilute hydrochloric acid. The same thing here too, dilute HCl, but this time around the calcium triiodocarbonate is not a powdered one, solid CaCO3. Let me use only 2 now. If you consider these 2 reactions, which of them will the CaCO3, which is calcium triiodocarbonate, dissolves faster? Which of them will have a faster rate of reaction? Is it the powdered or the solid?
The powdered one.
The powdered one. Why is that so? Because the surface area is greater. Because remember we said the smaller the size, the faster the rate of a chemical reaction because of a greater surface area. So once your surface area is small or the particle size is small, the faster the rate of a chemical reaction. So that is for surface area and how it affects the rate of a chemical reaction. Is that okay?
Yeah.
Any question?
No.
Okay, so that is for surface area. So we'll go to number 2, temperature. How does temperature affect the rate of the chemical reaction? Temperature. What is kinetic energy?
Energy in motion.
Okay, energy possessed by body in motion. Now, for temperature, you can write it this way. An increase in temperature brings about an increase in the average kinetic energy of the colliding particles. An increase in temperature brings about an increase in the average kinetic energy of the colliding particles, which in turn brings about an increase in the number of effective collisions, thereby leading to a faster rate of a chemical reaction. So it's very simple. Once the temperature in a nutshell, an increase in temperature brings about an increase in the kinetic energy of the colliding particle. That means the particles will begin to collide faster because of that increase in kinetic energy. That means the rate of movement increases. And once there's an increase in the rate of movement, there's every tendency that the particles will begin to collide faster. And once there's an increase in the rate of collision, there automatically becomes an increase in the rate of a chemical reaction. Is that taken? Madam Agatha, did you get it?
No, please, can you come again with the last sentence?
Yeah, exactly. Because I could rephrase it like I don't know.
When you said an increase in temperature brings about an increase in the average kinetic energy of the colliding.
Which brings about an increase
Okay.
in the rate of collision. So when there's an increase in temperature, this is it. So you can put it in your own way of the way you understand it. When there's an increase in temperature, there will be an increase in average kinetic energy. So the sequence continues. And once there's an increase in kinetic energy, there will be an increase in the rate of collision. Okay. Once there's an increase in the rate of collision, there will be an increase in the rate of the chemical reaction.
Wow.
Yeah. So that's how the sequence is. And then vice versa. So once there's a decrease in temperature, there's a decrease in the rate of collision, there's a decrease in the rate of the chemical reaction. That's okay.
Yeah.
Okay. There's a particular question I saw in WIEC. I know that I don't have my 350 handy at the moment, but I think I can rephrase it. Let me just paraphrase. I think the question was, with respect to kinetic theory, explain how temperature affects the rate of a chemical reaction. With respect to kinetic theory or something like that, explain how temperature affects the rate of the chemical reaction. So everything we just said now is the answer there. Once there's an increase in temperature, so the keywords there, you should follow it. An increase in temperature brings about increase in kinetic energy of the colliding particles, brings about increase in collision, and brings about increase in the rate of the chemical reaction. That is for temperature. Is that okay?
Yes.
Okay, so let's go to pressure. Pressure is similar to temperature, but the only thing let the student know is that pressure is only applicable to gases. Pressure is only applicable to gases. And once there's an increase in pressure, there's an increase in collision rates, and there's an increase in the rate of the chemical reaction. So once there's an increase in pressure, there's an increase in the number of effective collisions. Can be that way. There will be an increase in number of effective collision, which brings about an increase in the rate of a chemical reaction. Any question?
Okay, so the difference is just that the pressure occurs in gases only.
Yes, that's just the difference. Pressure is for gases. Mm. So if, for example, I have something like this, N2 plus 3H2, like in the case of other process, this is gas. Are you with me?
Yes.
Okay. In an example like this, once you increase pressure, it will affect the rate of the reaction because they are all gases.
Okay.
But if assuming this is solid, and maybe liquid, or that there's no gaseous reactant or product at all, pressure will have no effect on that reaction system. If you like, increase the pressure for now till tomorrow, or reduce the pressure, it will not affect the rate of the reaction because there's no gaseous reactant or product. So that's what we talk about. That's why we say pressure is only applicable to gaseous reactants or gaseous products only. That's it now.
Okay, yes. So increase in pressure,
yes,
we automatically lead to increase in the rate of reaction.
Yes.
And vice versa, if it is decrease in pressure too.
Yes.
Yes, thank you.
Welcome. So the next is effect of concentration. That is in terms of concentration now. How does concentration affect the rate of the chemical reaction? Can anybody try? How does concentration affect it? Hello?
Hi.
Okay. So for concentration, let me give you a simple illustration. Let's assume you are very hungry, and you see your favorite meal on the table. I'm very sure your appetite will increase. And you will so pounce on the food that people will be wondering, are they chasing you on the food? Calm down, take it easy. Why? Because you are so hungry. And if you get to a point that you finish the food, you wish that, hey, I wish this would come back again, or I wish this food will not finish. So in terms of concentration, once the concentration increases, the rate of the reaction increases. Let me draw a very simple diagram now. I'm not good at drawing. So if you laugh at my diagram, I will tell you to come and draw your own. Let's assume both of them have the same volume. That is, the volumes are the same. So depending on how you are seeing the diagram. So just assume that the volumes are the same. This is A and this is B. And looking at both of them, which of them do you think has the higher concentration? A or B? Hello?
Hi.
Okay. The concentration of A is higher. Why? Because the dots that you are seeing, like the particles inside, is high. The concentration of B is less than A because the dots inside, like the particle inside, is lesser. So if that fact has been established, what do you think will happen to the rate of collision between A and B? Which of them will the particles collide faster?
That means the one of B will collide faster.
B.
Okay. The one of B will collide faster, but that is also wrong.
Yeah.
Why? Because the particles of A are more close to each other than the particles of B. So because the particles of A are closer, there is every tendency that they will jam each other, that is collision. Unlike this one, the particles are far apart. So in terms of concentration, the higher the concentration, the higher the rate of collision because the particles are close. and the faster the rate of a chemical reaction.
Please come again with that sentence. Sorry.
Okay. The higher the concentration, the higher the rate of collision, and the faster the rate of a chemical reaction. The higher the concentration, the higher the rate of collision, always use the word effective, and then the faster or the higher the rate of a chemical reaction. So that is for concentration. Once the concentration increases, there's every tendency that the particles will collide faster. And then once they collide faster, there's every tendency that obviously the rate of the reaction increases. Is that taken? Is that taken?
Yes.
Okay. So you can, when explaining, you can use this same diagram to use and explain to your students. Let them understand it from that angle. So again, you can also use a very simple example. If you put 100 students inside the classroom where you are teaching, you can give them that sense. I don't know, you can picture how your classroom is and picture 100 students inside that classroom. And you tell them, okay, the canteen, they are selling canteen or they are doing giveaway in the canteen for free. The first person to get there will receive it. Let them run out of the class, whereby there's only one exit. What do you think will happen as they are running out?
Collision.
Did you get that explanation?
No, really.
Okay, let me come back again. When teaching this aspect, when you get to this aspect of concentration, before you even give them the notes, give them this example that if you put 100 students inside the classroom now, whereby you are teaching, and all the doors are locked with the exception of only one, because I know government schools know they have various exit routes, windows are open. But let's assume the windows are all closed and only one exit is left open. And they are doing giveaway in the canteen. That means canteen is free. The first person to get there receives something from the canteen and tell them, oh yeah, on your mark, move now. What do you think will happen as they are running out?
There will be a collision. They will collide with each other.
They will be colliding and the rate of collision will increase because the particles are closely packed.
Yes.
Now again, now tell them, if we have only those 3 students inside that same classroom, which of them will get to the canteen first? Is it the classroom with 3 or the classroom with 100 that will get the fastest student to the canteen?
It's the class with 100.
No, the class with 100, because the particles are closely tight. As someone is running, someone will set leg for the other person before that.
Yes.
For the one with just 3, there's enough space for them to run out. So the one with 3 will get to the canteen first. That means the rate at which the reaction will proceed is faster because the collision is less. That is, now let's get back to this. Once there's an increase in collision rate, there will be an increase in the rate of reaction. And once there's a decrease in collision, there will be a decrease in the rate of reaction. So that is that. Let's move on to the next one. Effect of light. We are taking longer time on this. Effect of light. Are we ready? Hello?
Yes.
Okay. Now, for light, some textbooks can say effect of sunlight. So we say effect of light, whichever way you put it. So, have you ever wondered why are reagent bottles dark in color?
Yes, I have.
Okay. So, if you wonder that, what is your conclusion? Or why do you always keep some certain reagents inside the cupboard, not on the shelf where it can have access to maybe light? It is because of this same purpose, light. There are some chemical reactions that proceed faster in the presence of light. Hence, reagent bottles are dark in color. This one is only in theory questions when it comes to, or more or less, practical aspects. Number 3 questions in why are reagent bottles dark in color when they give some kind of question? They are bonus. it is because of this purpose. Some reactions proceed faster when exposed to sunlight. A very good example of such reactions are one, decomposition of hydrogen peroxide. So in case I give the student those examples, decomposition of hydrogen peroxide. What's the formula for hydrogen peroxide?
H2O2.
H2O2. It is liquid. When it decomposes, I will get H2O and O2. This equation balance. Is it balanced? Hello?
No, it's not balanced. It's not balanced.
Okay, so how do we balance it? Balancing chemical equation.
It's to put we put 2 at the hydrogen side. That is the both reactants are products.
If I have 2 products and I have only 1 reactant, so where am I putting it? Is it on the product side where we have, or on the reactant side?
Both sides.
2 at the hydrogen peroxide and 2 at the
2 at the yes.
Okay. Then 2 here. It will rebalance like this. So
Yes.
will give me liquid, which is, and this will give me this. So this reaction is a decomposition reaction. And this is hydrogen peroxide. What is the use of hydrogen peroxide? Hydrogen peroxide is used as a disinfectant. When you were growing up, if you had injury, your parents will say, "Oh, let's clean it with." You can even use it as a first in your first aid box in school. You need to see hydrogen peroxide inside it. Yeah. It is used as a disinfectant, that is to clean wounds. Now, this hydrogen peroxide is always kept in dark bottles. That's it. And it is always kept in dark bottles because of this reason. Because if hydrogen peroxide is left open, or if hydrogen peroxide is kept in a transparent bottle, sunlight will have access to it. And when sunlight have access to it, it will decompose to give me water, and oxygen gas will be given off. So this is an example of a reaction that is affected by light. And this rate of decomposition proceeds faster when exposed to sunlight. Any question? Any question? Any question? Hello?
Sorry, because of the network, I couldn't get.
Okay, where exactly? Where exactly did you not get? So I will just quickly explain. The time is running out. So, your network is cracking. I can't hear you. Sorry. Hello?
Hello?
Okay, can you hear me now?
Yes, we can hear you now.
So you didn't get where?
And you know when you were saying that if hydrogen peroxide is exposed or put in a
Hydrogen
lighter
peroxide
bottle,
is exposed or kept in a transparent bottle, this reaction will take place. So the hydrogen peroxide will no longer be hydrogen peroxide, but to be left with water because oxygen gas will be given off.
okay.
And hydrogen peroxide is used as a disinfectant to clean wounds. So if you expose it to where there is sunlight, in a period of days or weeks, the strength is no longer there. It becomes water. So when you are cleaning the wound, you are using water, not hydrogen peroxide anymore. So that's why it is always kept in transparent in dark bottles, or it is kept in a cupboard where it will not have access to sunlight. So apart from the composition of hydrogen peroxide, other examples of reactions that are affected by light also have photosynthesis. You can write that one also, photosynthesis. You can also see, right, reaction of hydrogen and chlorine is also another example. Photosynthesis and also reaction of hydrogen and chlorine. We are left with 10 minutes, and after which we'll close for the day. So maybe next class, we can now look at exothermic and endothermic reaction. Are you there?
Yes.
Okay, so let's look at the last one, catalyst. Catalyst. What is a catalyst? You can try. Just try. There's no harm in trial. Time is running out. We must finish this.
Catalyst increases the rate of a chemical reaction by speeding it up.
Okay. I always tell my students not to use that definition. Why? Because if you are using that definition, you are talking about a positive catalyst. So to be on the safe side, a catalyst is a substance which alters the rate of a chemical reaction. Use the word alter. So that word alter is simply now left for the person to think, is it increasing it or reducing it? So a catalyst can either increase the rate of a reaction or reduce the rate of a chemical reaction. Is that okay?
Yeah.
So catalysts are substances which alters the rate of a chemical reaction. Taking?
Yes.
Yes.
Okay, now, right? This is done by providing an alternative pathway for the chemical reaction to occur. Someone, where's that noise coming from? This is done by providing an alternative pathway or by lowering the activation energy of the reacting system. In case they ask the student, how does a catalyst affect the rate of a chemical reaction? It is done by, it affects the rate of chemical reaction by lowering the activation energy or by providing an alternative pathway for the reaction to occur. Any question?
Oh.
Okay. Then we can just list this one. Types of catalysts, we have two types, a positive catalyst and a negative catalyst. Positive catalyst increases the rate of the chemical reaction, while negative catalyst reduces the rate of the chemical reaction. Positive catalyst increases the rate of the chemical reaction, while negative catalyst reduces the rate of the chemical reaction. Is that okay?
Yes.
Okay. Again, a positive catalyst increases the rate of the chemical reaction by lowering the activation energy, while negative increases the activation energy. I'm rushing it because I want to finish this, so sorry.
Okay, sorry, please. Can you please take that one again? I'm trying to jot it.
Okay, wait on again. So we have two types of catalysts, positive and negative. Positive increases the rate, while negative reduces the rate.
All right.
Then the positive lowers activation energy, negative increases activation energy. Is that taken?
Yes.
Then properties of a catalyst. Quickly, I should finish that in the next 4 minutes. Properties of a catalyst. 1, catalyst cannot start a chemical reaction. They are only effective in a reaction that is already in progress. Catalysts cannot start a chemical reaction. They are only effective in a reaction that is already in progress. Is that taken? Number 2, catalysts are required in small quantities. Catalysts are required in small quantities. 4 or 3 rather, catalysts do not determine the type of product formed. catalysts do not determine the type of product formed. Is that okay? Hello?
Yeah.
Okay.
Yes.
So how many now?
3.
Okay. Catalyst works on the principle of lock and key. Catalyst works on the principle of lock. These are to write it, lock and key. This lock and key simply means that catalysts have what we call the active site and the binding sites. This one is for those if you want to go further. That is biochemistry, so let me just leave it at that. Catalyst works on the principle of lock and key. I think that 4 is enough. Most times it's always list 3 properties of the catalyst. They are not, they don't take part in the chemical reaction. I think we have written that already. So catalysts do not take part in the chemical reaction. They cannot start a chemical reaction. That's another one. I'm just trying to recap what we've written. Then they are required in small quantities. They work on the principle of lock and key. So then that's that. Any question now? So we can stop here. So next class we'll be looking at exothermic and endothermic reaction. But for okay, I have 2 minutes more. So you quickly use these 2 minutes to draw this diagram. This is the energy profile diagram showing the presence of a catalyst. Reactant, product, reaction, pathway. Up here is energy. An invisible line. This is from here to here is called EA, activation energy. From here to this point is called enthalpy change, H. Up here is called TS, activated complex or transition state. Did you get that?
Yes.
Okay. Now, this is what I want to draw now. I will draw an invisible broken line. These both broken line are not invisible because you can see it. A broken line. This broken line tell me the catalyst, that the catalyst is present. Because we say catalyst lowers activation energy, so that this catalyst now is making the reaction, instead of going this high for the reaction to go to completion, it will reduce it down. So this thick one is called uncatalyzed reaction. Uncatalyzed. That means there's no catalyst present. While this broken line is called catalyzed reaction. Okay, you're shutting down in the next 1 minute. So quickly draw this diagram before it goes off. Any question?
No question.
Okay. Thank you very much for your time. We'll do this again on Wednesday.
All right. Thank you. God bless you.
Thank you so much.